Hi, everybody. Welcome to the .NET Hampton Roads.NET user group. I'm Kevin Griffin. I'm joined by my cohort, Drew. How are you doing today, Drew?
Doing well, and you, sir?
Doing very well. So you all have the luxury of recording this at 6 o'clock in the afternoon. It is 11 o'clock where I am in London, England. I'm attending the NDC London conference right now and totally forgot that I had scheduled the user group. That's why I clicked on. So I'm doing this from the comfort of my hotel room. So if I start yawning a lot, it's because it's very late here, and I've been in the pub a bit, so I'm a little tipsy. Um, but that's not why you're all here. You're all here because we want to learn about Azure machine learning from my good friend Shahed. I've known Shahed for years and years and years, and he's jumped all over Microsoft. I knew you before you were at Microsoft. Dang, I don't remember what company you were at before Microsoft.
It was Excella Consulting
Excel.
in Virginia.
That's
Yeah.
right. So I remember when Shahed had gotten into speaking, and he's come a long way since those good old days, right? So we are very glad to have Shahed. Would rather have Shahed down at the Hampton Roads group in person, but we're still doing the virtual thing at least for a couple more months, just see how we're feeling and see how general folks feel. But we have a good lineup for the next couple of months. We'll talk about that here towards the end. But for now, Shahed, I'm just going to turn it over to you. I'll let you do your thing. Everyone out there, if you're watching either on Twitch, YouTube, or LinkedIn, if you have any questions at all, drop them into the chat, and Shahed will answer things as he sees them pop up. And yeah, I think that's all I got. Shahed, it is all you.
All right. So as Kevin mentioned, I'm Shahed Chowdhuri. I work for Microsoft. Been here, I guess, over 8 years now, but I've had very different roles since then. I joined as a tech evangelist, which was that public speaker role that Kevin had alluded to. Right now, I'm more heads down, hands-on projects for customers as a senior TPM or technical program manager at Microsoft. But public speaking has been something I've always wanted to do for a long time, and I haven't had a chance to do it lately for the past couple of years. So this year, I'm trying to start to get back in. I've done this Azure machine learning talk earlier this year, and wanted to take a chance to meet up with Kevin and talk to his group. So it is over just past 6 p.m. Eastern time here on the East Coast, US. But you may also catch me yawning as well because we have a little one at home now who likes to get up at weird times. So may not always be at my best at all times, but I will plow through this and ready to answer any questions during this presentation, but also afterwards. I'll leave you with my Twitter handle. You can catch me online, or you can email me at shahed.chaudhuri@microsoft.com. So it's just first name dot last name at microsoft.com. So with that, I will go ahead and get started. We do have some slides to visualize things we'll talk about, but we'll go ahead and take a look at the actual tools as well. When usually if it's just live code, let's say if some .NET application, I can type the code live and show you examples as it happens. But machine learning, as you may be aware, some things just take a long time to run in the background. So instead of you having to sit there for the full 2 hours, I've run things ahead of time so that you can see the end results, and we'll walk through all the steps. So I've captured all the screenshots as well. So it'll be like you're going through a fast forward version of a live demo. All right. So let me go ahead and run this. Hold on, let me try that one more time. All right, so Kevin, you should be able to see the main screen in full screen mode now.
Yep.
All right. So our agenda for today, we'll go over a quick intro of what we're covering with machine learning, specifically in Azure machine learning. We'll go over some of the roles in AI and ML today. You always hear about artificial intelligence and machine learning, a bunch of buzzwords in the industry. But people are not always aware of what kind of roles fit into these categories, and also what you can do with the skills you currently have. So I have a development background myself. a program management, project management, and public speaking, and a bunch of other different backgrounds. And during that time, I've gained some skills that allowed me to enter into Azure machine learning and use some of the tools that are available, learn some Python coding, and also use some of the automated tools. So the third bullet item here talks about AutoML, or automated machine learning. We'll talk about how we can use AutoML in Azure for all the different steps we have: building and training models, validation, deployment, and wrap up with monitoring. And throughout this whole thing, we'll explain each of those concepts and wrap up with a summary. So as Kevin mentioned, we do have a full 2 hours today. I won't go that long, but that'll leave plenty of time for questions. So with that, let's go into the introduction. So you've seen ML in the news, I'm sure, in social media and other places. I wanted to highlight two articles here out of many. So the one on the left talks about one real life application for machine learning, talks about how it's making fruits and vegetables more delicious, something you don't typically think of when you think about machine learning. So every time you're trying to solve a problem, you think about the different pieces of software you can build. Now, software development is a little different from machine learning, which is in the realm of data science and artificial intelligence. So it's a different kind of beast altogether. So we'll go through some of the steps and how you can take your software development background and use it for machine learning, particularly for machine learning in Azure. And on the right here, it also talks about some of the demand. So this one talks about how everyone's fighting to hire machine learning engineers, and it gives a sample salary. So obviously they'll vary based on your region and your background and experience. But just goes to show you that between real life applications, things you may be interested in, things that may be important to you, and all the demand that's all over the place, especially with so much remote work these days, and companies trying to figure out how to run their businesses better in this new world. There's always some way that you can use ML in something in some new ways possible. Uh, a lot of projects, ML projects at companies fail, but that does not mean that it was a waste of time or money. Because a lot of the times you may want to assess whether something can be done or not, and the end result is that you conclude that you started to do something and it's just not possible, or it's just not possible with the data you currently have, and that's perfectly fine. Uh, we'll talk about different phases of machine learning as well. But with that, um, let's cover the end-to-end process. So we'll learn the end-to-end process of how to use Azure machine learning, and specifically how to use automated machine learning to build and train machine learning models. And just to clarify what this is not a Python language tutorial, although at the very end, I'll provide some links to some excellent YouTube videos that Microsoft has for free to learn Python at different levels, starting from the super beginner to more advanced topics in Python, and how you can use it for ML. And this is also not a deep dive into all things ML or AI. That wouldn't be possible in a quick intro presentation. Maybe if I do a more advanced presentation at a different date, I might be able to cover a more deep dive into more topics. So we know what it isn't, but what is machine learning? This sentence here, I'll read it out loud, then I'll explain some parts of it. Machine learning can be used to generate classifications or predictions from trained models that receive input from some existing data. So let's work backwards in the sentence here. So notice that I added some existing data to this definition, which you'll find in several different definitions, no matter where you look. Now, the existing data is important because you have to have something to start with. So let's say if you're trying to predict health information about a certain age group, you'll need some existing data to start with. Maybe you have to do some surveys or gather information from data that has already been collected. Maybe you'd like to figure out some better ways to improve sales for your company. You can look at past sales data and figure out what makes consumers tick and what makes people buy certain things certain times of the year and so on. So that's where the existing data comes in. So the trained models is what you build to be able to add in your input data. And the two things that we generate are the classifications and predictions. Now, classification, you can think of it as specific groupings, whether something is classified as one or more things. So let's say there's two classifications, A and B. You want to determine whether something is A or B. There was a humorous app called Not Hot Dog, where the app, all its purpose was to just determine whether something is a hot dog or not. So for something like that, it would be fed in, no pun intended, lots of different images of hot dogs and things that were not hot dogs to try and train it on what a hot dog is. So that way it would see a hot dog, recognize it. If you're wondering, well, why is that useful? So that's useful because let's say you have something fun, have some fun with it, and build something that's funny and stupid. But in the end, maybe you can have something, an algorithm that tries to figure out whether there is a pet crossing the street. So when you have an automated car driving around, it's not just looking at road signs and other things. Maybe you can look at a real dog, right? A real dog, real cat, or other animal, try and figure out whether an animal is about to cross the street so the automated car can stop. And maybe not only stop there, but go one step further and trying to match maybe a specific dog with other missing dogs that are in the area. So that way, see how you start talking about machine learning and different applications, and you can start talking about other ways you can use the same application. So whatever project you're doing, either by yourself or for work, or maybe you're joining some open source project, the ideas are never ending. So don't let that stop you. If you've just hit a brick wall, think about what you can build right away, and let that take you to the next level. Now, predictions, it's pretty self-explanatory. You're trying to predict something based on past data. Now, as a stock trader myself, I will say you cannot use past information to accurately predict or expect specific stock prices going forward. But there are other things that can be predicted. So let's say when people do stock analysis, they're looking at the fundamentals of companies and doing a technical analysis. And there are a lot of analysts that have price predictions or target values that they set for maybe the next 6, 12 months, what have you. There are people who predict the weather based on information they've gathered. And again, we've seen how that works out sometimes. The weather prediction tells you that there's going to be some rain, but it turns out there's no rain, or vice versa. So predictions can have certain levels of accuracy. Now, accuracy is important. You can look at the accuracy levels and use that to improve your predictions over time. And we'll take a look at a real life example with some health data later on in this presentation. All right. And I'll occasionally look over to the chat window as well. Right now on my side screen, I do have the notes side of the PowerPoint slides. So as you probably know, PowerPoint opens up another slide. So Kevin or Drew, if you have any questions in the chat, or if you need to ask something or comment something, just feel free to unmute yourself and speak up. All right. So what is an ML model? Excuse me for 1 second while I cough to the side and take a sip of my drink. Excuse me. Sorry about that. So what is an ML model? So I had hinted earlier that you would train an ML model with using a data set as input, and an algorithm to extract some of the learning or predictions. So the square box over here has the words ML model in bold. And let's say you enter in the training data as mentioned earlier. Notice there's another set of data right here that says test data. So you're not only training the data or training the model with some initial data, you also have some test data that you can all feed to some algorithm, and that generates some level of output, which you can then use to retrain. If you remember earlier, I talked about how we can have certain levels of accuracy with different algorithms. And if you're not happy with that, there's ways to retrain your models to make sure that you get more accuracy over time. Now, one thing to note is that you shouldn't be just grabbing data from two different places that are unrelated. Usually, your train and test data comes from the same data set, as we'll see in the example going forward. And you would use a certain split, a test train split. The amount of data you'd use for training versus TED varies, but you would definitely split them and not reuse the data on both. You may be wondering, well, why can't I use the same data for training that I use for testing? One of the reasons is that it gives you some unfair results if you use 1,000 or 100,000 data points for training, and they use the same 100,000 data points for testing as well, just your test will probably say, hey, based on the data that was inputted, I predict this and this results. Um, and you would most likely be correct almost all of the time, if not all of the time. And that is not a good model because you're using the same data for training and testing. So you definitely don't want to do that. You want to make sure that you're getting it from the same data source, but data set, and you're also splitting that up so that the piece that you use for training is different and separate it from the piece that's used for testing. All right. So we mentioned machine learning a bunch of times. So what types of machine learning are there? One type that's commonly mentioned is supervised learning. That's data that's already been labeled. You can see it on a spreadsheet and it's nicely tabular and so on. Um, can be used for both classification and regression. Um, Classification we touched on briefly on categorization of people, etc. So this can also be used for image classification, like that hot dog, not hot dog app I mentioned earlier, and also used for regression. So regression refers to numeric predictions. And again, I've mentioned both weather report and stock prices earlier. The other type is unsupervised learning. This is more unlabeled data, so then it's up to you to find the patterns in the data that's available. And some sub bullets for this could be clustering or dimensionality reduction. So for the clustering, this could be recommendation from whatever streaming app you're using. So you may recall that Netflix used to have some sort of bounty for people who would develop machine learning algorithms that would provide better recommendations, a good recommendation engine, because they're willing to pay for that just for some random person to help improve their recommendations, just so that all their millions of customers can log into Netflix and see things that are being recommended. So again, very useful for all the sporadic data that may be available. And then the next one item here is for visualizing big data. So we won't go into big data today, but if you've heard the buzzword enough times, instead of just having simple relational database systems, we live in a world where there's infinite data points and just streaming data and all sorts of data that's available, and you want to get some level of visualization, unsupervised learning may be useful for you. I did want to add also reinforcement learning. Excuse me. I did want to add reinforcement learning as well, and this is for things like self-driving cars, AI, video games, or AI in video games. Now, this again is a very deeper topic that we won't be getting into today, and but this is something that everyone should be familiar with. Either you've played some a level of video games, or you're familiar with self-driving cars on AI. Now, when people think of AI, they might tend to think of robots. In layman's terms. But AIs don't need obviously a robotic body. You could use a chatbot or a virtual AI, just code running on some server somewhere. So it could be any sort of artificial intelligence that helps in decision making. So we will be focusing on classification under supervised learning today. So just goes to show you there's all sorts of machine learning, and there's so many topics to be covered. So we'll focus on something really small. I did promise you I was going to talk about roles in artificial intelligence and machine learning. So I put out these four different roles over here. Microsoft's documentation, they cover in detail the first three, but I wanted to add the fourth one as well, and I'll explain why, because that's the background that I came from. So for a data scientist, a data scientist is someone who develops models. So those different machine learning models you see that are mentioned, data scientists will be involved in developing better data models that can then be used for improving their algorithms. But when you're doing a lot of this work, whether it's in the cloud or on-prem, you might need data engineers to provision your data source. And we'll take a look at a little more detail on what else a data engineer does. But if you think about the infrastructure that's required to be able to set up your environments and do deployments and just store all the data that you're bringing in, the data engineer person takes care of that. And then you have the AI engineer. And I mentioned here the AI engineer as intelligent capability. So let's say you're using something like Microsoft's chatbot framework to build an intelligent chatbot, then you might be able to just reuse existing code and libraries and services that have already been used to be able to use some intelligent conversation plugins such as Lewis, which is Language Understanding Intelligence Service, I believe. I forget what it stands for, but it's LUIS, and is used with chatbot framework. And it's used to make better chatbots that can do live conversations and just conversations back and forth. Now, I added the app developer at the end because you can start using what other people have built and add those to your own product. So let's say you're building desktop apps or mobile apps, and you have no idea what any of these other people do. Well, that doesn't mean that you can't work on an AI or ML project. You can totally tap into any product that maybe has an API, a REST endpoint that's available. You can send your payload and get some data back, and not worry about any of the different roles and tasks that other people have worked on. Now, if you feel that one or more of these roles are interesting to you, then you can move from one to the other, where you can gain some additional skills or be able to just go on a deeper dive into that area. So that was a quick recap of these four roles: data scientist, data engineer, AI engineer, and app developer. I did mention that Microsoft has some descriptions on their site and their documentation about all these different roles. So I did want to highlight a couple of these. I'll zoom in on this one. So the AI engineer, again, I had mentioned some of the cognitive services that we work with, including the Lewis service, but also mentions things like computer vision, text analytics, and Bing search, and so on. So let's say you're able to take some text and you want to do some analysis on it to be able to maybe extract some sentiment analysis on how people are talking about a certain topic. You can use existing services to be able to get that intelligence. You don't have to build everything from scratch. I mentioned the data engineer helps with setting up the infrastructure. So notice this covers both on-prem and cloud as well. And this includes the different types of data storage you may be familiar with, including relational and non-relational databases as well. And finally, we have the data scientist, which we had mentioned at the beginning. So the data scientists do all the crunch work to be able to do those analytics to get some value from data, because data is kind of useless without getting some sort of intelligence from them. I did want to highlight this one term here. It says EDA, exploratory data analysis. At the very beginning, I had mentioned that your AI or ML projects can be successful or may not produce the results you need. So one process that the data scientists go through is an EDA that can happen at the beginning of a project that can evaluate the data just to see if it's useful or not. So again, just because your end result says, hey, I can't go any further than this, doesn't mean you're dead in the water. It just means that you can't proceed further with the information you have today. Okay. All right, so now let's get right into AutoML in Azure. So I mentioned this earlier. Azure Machine Learning has something called automated machine learning that helps you automate, really point and click, and create some resources in the background and be able to upload some data, get some predictions. But at the same time, you can pair it with your existing Python code or new Python code. So we'll take a look at that towards the end, but we'll focus on the AutoML for most of this. So what is AutoML and what is it not? So on the left side, talk about what it isn't. It is not a replacement for coding. So let's say if you're used to doing everything from scratch and just writing Python code using some libraries, so on, this is not going to replace it. On the flip side, it complements your code. So it's a good thing. It helps you be more productive if that's your thing. And on the left side, I do mention this, not just point and click for beginners. It is also useful for ML experts for more productivity. So it's not just something that you would start with, although you could certainly start with it if you have no experience with Python or any machine learning whatsoever. But once you gain more experience and you're working on more advanced stuff, you could continue to use something like AutoML as well. So it's not just a stepping stone. But just a word of warning, it is not a complete solution for all types of algorithms. So right now it's still a fairly new product, so it has a limited set of algorithms and models available. But we'll take a look at what it can do today. And immediately we'll see that there are some things that are in preview mode. Every time something is released in Azure in preview mode, you can get a sneak peek at how it works. You can provide your feedback to help the Azure team improve our products. So how do you get started with this? if you go to the Azure portal, which is portal.azure.com, or you could just go to azure.com directly and click on the sign in link on the top right. You would search for the machine learning item to set up your own workspace. And then once you create the workspace, it looks something like this. So what I'll do at this point is I am going to get out of the PowerPoint so I can focus on the browser. So give me 1 second while I open this. So here's what my workspace currently looks like. I'll zoom in just a little bit more so you can see more clearly. And you'll see a bunch of tabs over here. You don't necessarily have to go line by line and go through each of these just to build something. You would start off with one of the items here. Either you can go right into your notebooks and start building with the Python SDK. You can start with an automated ML system and start training your models. And we'll use a target metric in our example. Or you could use a drag and drop designer as well. We won't be using the designer today. So if we click on Start Now with Automated ML, you'd go to this process here, and initially there won't be anything here if there's nothing at all, but I had already done an AutoML run previously. So you can see it has the last night's date on it. And in that ML run, you can see that it has a status of completed. But also you can see that it took a long time, about an hour and a half to run through this whole process. Now, what did it run through? If you look at the child runs tab, you can see at the very bottom, there's 3 pages of these different runs. And in case you're wondering about these display names, they're just using dictionary words, so they're easy to find. So let's say you're working with your colleagues or your project partners, and someone talks about a data run that ran at 12:13 a.m. last night. You can just say, oh, yeah, let's look at the Dreamy Cake run. So you can go ahead and click on that one. And these are just randomly generated. So what we'll do is, again, switch back to the PowerPoint. Again, to recap, automated ML is what we're focusing on. And initially, when you start, this is what it looks like. And I would click on New Automated ML Run to get started. So without boring you through the whole hour and a half process, I have the screenshots for building and training models. So when you first start with it, you'll notice that there are 4 steps over here. Select dataset, configure, run. You select some task and settings, and you validate and test, which is an optional setting, but we'll go through that as well. Now, when you select a data set, there's a couple of different options here. Again, you can select something from your local files, from a data store if you've already uploaded something, from web files if you want publicly available information. So let's say you don't want to download it and re-upload it again. There's a website called Kaggle, Kaggle. There are a lot of different experiment ideas and different data files available. You can get stuff from there, save it locally, upload it to your data store, or grab it directly from the web. So again, different ways of doing the same thing. And of course, there are some open data sets available that you can browse through. So in our case, I had already downloaded some files, and I was able to get it from my local file system because I'd already downloaded and saved it locally. And I called it My Data One. Again, it takes around a second or so. Every time you see something that's taken a while, it hasn't appeared yet, if there's a refresh button, you can click the refresh button to see if it appears. Uploading a data file doesn't take that long. It's fairly quick. So after you open it, it allows you to create a new experiment and assign a target column. Now, let's go over to my spreadsheet here and show you what I would use for target column. So this is the Excel version of the CSV file that I uploaded. So again, CSV stands for comma separated values. When you put it into Excel, it creates this tabular data format. Now I've squeezed it enough so you can see all the columns here. So here is a series of columns that have different data points and a bunch of data that I grabbed from Kaggle. And the last column here has a Boolean, either 0 or 1, which is essentially true or false, whether someone has heart disease or not. Well, what if you fit into one of these, or you want to enter your own values for, let's say you've had some different medical tests done and you know all the different values you have. Are you most likely to have heart disease or not? Should you get it checked out? Now, again, disclaimer, Obviously, I'm not a medical doctor, so please do not try to enter values here and get worried that you may have heart disease. Always check with your doctor. Okay. So to be able to add this, I selected heart disease as the target column. So notice here it says integer in parentheses. So it's detected that it has ones and zeros in there, and I can extrapolate later on to figure out whether it'll return true or false. Now, it also asks you to select a compute type. Now, you can select a single compute instance, which could be one virtual machine, or you could select a compute cluster where you can select one or more nodes, which is essentially multiple virtual machines. You can make them grow and shrink as needed. So in my case, I selected a cluster when I took the screenshot. And then I clicked on the additional configuration tab for classification and I select their primary metric setting. And this one, the term here is AUC weighted. We'll check the definition of that shortly. But in this case, you have several different checkboxes. I didn't go through all the different advanced settings, but again, I'm using use all supported models, so you can use whatever is available to Azure Machine Learning, especially automated ML at this time. But I did want to show you this definition of AUC, or area under curve. Specifically, AUC underscore weighted, it's defined as the arithmetic mean of the score for each class. So class is a different category that it might someone might fit in. So in this case, the different categories are 1 or 0. Either I'm more prone to heart disease or I'm not, right? So the two different classes. And then the arithmetic mean is essentially the average. And if it's weighted, it's a weighted average by the number of true instances. So let's say when it exists more, it gets weighted more. And that's being used for the prediction in this case. Now, the next step over here for validation and testing, it mentions the validation type as k-fold cross-validation, and we'll describe shortly what that means. In this case, the number of cross-validations, you can set it to a higher number if you wish. In my case, I only set it to a number 2 to make it go faster. And as we describe it visually, we'll see why that's important. You can set a higher number for more validations. You can set a lower number if you just want to get it done with quickly. And finally, you'll notice the test data set says the word preview on it. As I mentioned earlier, as we create more and more features in Azure, when something's in preview, that's also available for the public to use if it's a public preview. And that way you can get to test that feature when they're available. In this case, the test split lets you choose how the test data is split between testing and training. So notice that the recommendation here is between 10 and 30 because you don't want to test with 50% of the data because you need a lot of data for training. In this case, 80 is being used for training the data, and you can use 20% of your data to test it to make sure that your accuracy is good. And then there's the finish button at the bottom that lets you wrap up the testing and validation stage. Now, I showed you earlier what it looks like when the run is complete. So in this case, in the details tab, it shows you that the process is still running in this case. But the next screen over here shows you the next tab over, the data guardrails tab. We'll take a look at each of these and what they mean. I'll describe what they are in this context. So here, the class balance and detection that it goes through, and again, these are data guardrails that all passed. For class balance and detection, it makes sure that all classes are balanced in your training data. So again, what does that mean? If there's an imbalance of data where you've gotten too much data from one classification versus the other, it may not be training well. So you want to make sure there's some balance available. And usually, if you're not the one collecting the data, if you get it from a reputable source, chances are it's well balanced. But regardless, Azure Machine Learning will be able to check it for you to see if it's passed or not. And if you're unsure of what else you can do, you can click on these links to learn more about imbalanced data and what you can do about it. So this is an interesting one: missing feature values imputation. So this one is described as it's saying that no feature missing values were detected. So value imputation implies that they're missing values, and it's going to figure out how it can fill in those missing values. You might be wondering, well, how does this help, right? That's not real data. So This is something that people smarter than me have put together over the years in this industry. And this is a valid way of being able to fill in the gaps for some data. So again, what you would be checking afterwards is check to see if there is any improved accuracy or not as you're improving your model. So again, just filling in missing values won't make your algorithm better, but over time you would still check the end results to see if your predictions are good or not. And the last one over here mentions hard cardinality. So in this case, they were saying, again, no such features were detected. I do have a more detailed slide on each of these. So featurization in this case, as going through all those guide rails, featurization is a keyword here in case you want to learn more about it. Mentions the hard cardinality. So in this case, hard cardinality is very unique values, such as things that are GOIDs or hashes, like really long, unique strings that are available that are not useful for doing the machine learning. Those are dropped. We covered impute missing values in the checks that were done. So in this case, it explains it a little bit more detail where the system replaces the numeric field with some average or some category with the most frequently used category. So earlier I'd mentioned that missing values are filled in case you're wondering how they're filled in. If they're numeric values that are missing, again, it fills in with just an average, so it's not something that's an outlier. And if it's some classification problem you're trying to solve and something fits in a category, yes or no, it's going to try and fit or replace that blank value with the most frequently used category. So that's already available more than anything else. In some cases, values can be transformed if it's appropriate. In some case, a numeric value, maybe that's an age, could be transformed to a category, an age range. Now, how is this useful? So let's say you have various different age ranges available in your data. So maybe there's people that are available in the data from age 0 to 120, right? And there's many types of data points available for each age. But you'd like to sort of shrink your data down and you want to group them into different age ranges. Maybe 0 to 18 is one group, and then maybe 19 to 25 is another group. Maybe they're not all the same sizes. So in some cases, it might be useful to be able to transform those numeric values to categories. And notice that that would change your problem solving from a regression problem to a classification problem. So again, it simplifies the problem you're trying to solve. Instead of trying to predict things for every single age range available, you're trying to solve it for different groups of age ranges, which may come in handy when there is some health data you're looking at, or maybe you're trying to look at generation interest, what kind of music people might like, and so on. Of course, there's always outliers because some people at earlier ages may have more health problems. Some people at later ages may have maybe more fit, or in case of interest based on age ranges, you might like something maybe music from your parents' generation and so on. The next featurization topic here is interesting. It's called one hot encoding for categories. Now, I'll read what I wrote here and then I'll try and describe it as best as possible. So the description here is transposed into columns filled with mostly zeros and a one for the category value. So what does that mean? Think of a database table where maybe you have a database of pets and the pet can be a dog or a cat and so on. So maybe you have one string value and it says pet type, and the string value says dog or cat or hamster or whatever pet that you might have. So for one hot encoding, this improves the ML modeling and training. What it does is instead of having just one field just for the pet, you'll have one field for every single type of pet. So let's say there's a Boolean value for is dog, is cat, is hamster, and so on. So for every single pet, there's only one thing, unless you have some sort of weird mutant creature that's a dog and a cat at the same time. I think there was a 90s cartoon called Cat Dog. Aside from that, you would only have a one for one of those fields. So let's say for each pet, for all the different fields, is dog, is cat, is hamster, and so on, there'll be 0, 0, 0, 0, 0. But for the animal that they are, it would have a one value. So again, this is called one hot encoding. Next one over, split date time. This is pretty self-explanatory. If you find more value in setting or splitting up a date time into different parts, year, month, day, and so on, maybe you want to group all the different months to see if there's more sales happening in December for some online store and so on. The next two over here, term frequency and BERT. I'm going to switch over to a website to describe it better than I could and see if I can describe that as well. So go over here. So go for the term frequency first. So for something like this, you'll see a unigram is literally just one word at a time, but a bigram is two consecutive words in a sentence. So if the sentence you're analyzing is the boy is playing football, the bigrams here are, let's say in this case, the boy or boy is, and so on. And trigrams are three consecutive words. So a lot of the times, I'll include this link as well so you can read this article in more detail. For machine learning problems, to be able to analyze written words, especially for natural language processing, bigrams and trigrams are used by the system in the background. So earlier when I mentioned that, coming as an application developer myself, uh, uh, I'm not familiar with all the stuff that the great data scientists do, but I can totally use existing services that are available, such as cognitive services and the Lewis tool with chatbots to be able to build an intelligent chatbot without doing all the background work myself. So as the different words in a chatbot stream is being translated and also analyzed, um, the system can go ahead and split the words up into the different unigrams, bigrams, trigrams, and so on, try and make use of the different text that is coming in and out. So again, natural language processing, you've seen that probably a lot in terms of how AI assistants are used, whether it's Siri on your iPhone or whatever the Google Android voices or Alexa devices that are pretty popular from the Amazon Echo devices. Whatever it is using in the background to do NLP and natural language processing, this system can be super useful. Okay. And then for the last item over here, BERT, which stands for bidirectional encoded representations from transformers. Again, really, this is a mouthful. It's defined as a language representation model, but what it's really useful is to pre-train deep bidirectional representations of unlabeled text. So what does that mean? In short, it can be used for language inference when answering questions. So again, this is a simplified version. It's the last line. So let's say you might be asking your chatbot, "Hey, what kind of trees can I buy at this time of year? Because I need to get a Christmas tree before the holidays." And then maybe you'd go to some tree reseller website that they'll tell you that's available. But in order to be able to process that information, it'll be able to then figure out what you're trying to ask based on questions that have been asked before, what is being trained with, and so on. Again, when you train a machine learning model, you need some sort of relevant data in case of trying to figure out how to answer questions for a specific type of store. You'd have to feed it maybe past conversations or information that particular chatbot will be able to answer. So again, the sky's the limit. I have included the link to the BERT page as well that describes it in more detail, so you can figure out what it means for you. So the child runs, as I mentioned, in the child runs tab, once you start, it could take over an hour. When I took the screenshots for the previous run, I showed that I had started at 8:33 and it ended at 9:25. So again, this can take a really long time. So in my case, on my runs, uh, so in tab, you're going to see that it picked the models. So this is the automated part of the automated ML. So instead of you manually trying to figure out what model should I use, uh, different models that are available, and it will choose the model. Trying to figure out. And in this case, there's also a note over here that says or the last 20 iterations, so the experiment stopped. So again, it might go longer than you expect it to, but if it figures out that based on the iteration you're at, whether someone has heart disease or not, or is more prone to having heart disease. I bolded a couple of these different ensemble learning types, stacking and voting. Stacking specifically refers to training using the output of other models, usually in multiple stages. And then on the voting side, making a prediction from the weighted average. So earlier, when we had chosen that AUC underscore weighted, that was specifically for making a prediction from the weighted average. So again, it would not only make the prediction, but check to see whether it was accurate or not. And again, I do have the sources listed over here. Towardsdatascience.com is a great website to view. And also automated machine learning with Microsoft Azure that really covers AML in great detail from Pack Publishing. So this validation step I had mentioned earlier, I just kind of glossed over it. I mentioned k-fold cross-validation, and I'd mentioned that you could choose a k value of 2 or more. In that case, I just chosen 2 to save some time. And I didn't go over what else is available. So in this case, you'll see I click the drop down, and the available values are just automatic let it choose, but I wanted to specifically choose k-fold. And the other ones available are Monte Carlo, trained validation split, and you can use your own validation data set. So the types of validation, again, I got this from towardsdatascience.com. So to summarize this, the k-fold cross-validation, the data set is split into, normally I would say like X number of equal parts, but in this industry, it's referred to as K. So let's just say K is a numeric value, K equal parts, and the model trains on K minus 1 block. So what does that mean? If there's 10 equal parts, so whereas K is 10, the model is training on 9 blocks, and then the last one is being used for a validation. So that way it helps to do some validation before it's using test data. The Monte Carlo cross validation is split more randomly and tested at arbitrary times. And the trained validation split, in this case, the data set is split into subsets as before, but the trained data set is used for learning, and the validation data set is used to evaluate the model that's fitted on the training data set to figure out what the best model might be. So again, there's pros and cons for either of these, any of these approaches. Again, I would recommend checking out the link in more detail. I'll share the slides with Kevin and also the meetup after the presentation. That way you'll have all these links yourself. But let's go a little bit more into k-fold cross-validation. So I'm going to go into my browser here. And I just searched for k-fold cross-validation and found this nice picture here from some website here, i2tutorials.com. And in this case, remember I told you if you have k equals 1, 2, 3, 4, 5, whatever the value is, first it's going to use k minus 1, in which case it's 4 of these blocks for training. And then it goes through all of them. So imagine a bunch of people standing in line, and each time you go around and you pick one person, says, okay, now you get to do all the validation. And then you switch to the next person. Okay, now you get to do the validation. So whoever is picked to be that uh, validation block, the other blocks are picked to be part of the training. So as you go through each of these, you're just making sure that you're able to validate your trained data to make sure that everything is being uh, predicted correctly or not. And I think the more um, the more you do, the you can improve data, but you've probably seen that Let me click that. My screen is currently on, so I've closed that window. And look at that, my mouse is super cool now, moving all over the place. So yeah, I had that open a while back, and probably some JavaScript was hanging in there. And as soon as I clicked next, it everything slowed down. So so if you're a JavaScript developer, make sure you check your code to make sure that if you have it running for a really long time, that it doesn't slow everything down. So I had mentioned that there are different types of cross-validation, in which case the careful cross-validation, the more you do, the more the accuracy you get. But after a certain moment when you pass a threshold where there's no more improvements, even Azure said, hey, you know what, we're good. We don't need to run any more iterations. So you can do that as well. All right. So after all that, all this stuff is useless if you can't see your predictions, right? So the deployment state helps us deploy what you've finally tested and validated. And in this case, you can choose to deploy a real-time endpoint or deploy to a web service. In my case, I deployed to web service. The real-time endpoint is still in preview, but you can use that as well. With this endpoint over here, I have two choices. So I chose the Azure container instance for the deployment. So instead of setting up a new web app service, which you've done before for web apps, just know that there is a container instance service that's available. You can run everything in the container, not have to worry about it. The other option here is AKS, or Azure Kubernetes Service, which I thought would be a little overkill for this demo. So I just chose ACI. And I was able to deploy, and it says succeeded. So once it's succeeded, I can now go to an endpoint by checking to see if the data can be predicted or not. So here I've highlighted the word experiments. You'll notice I do that a lot in my slides, where I highlight which tab I'm on or which sub-tab. That's because when you're going through one process, click a link, go to another process, you may be wondering, hey, what tab am I on? So most likely you're in one of the tabs that are here, or maybe one of the sub-tabs. So just keep an eye out for which tab is slightly colored differently. So here I have a very slight gray rectangle around experiments, but I just circle here to show you where it dropped me after I completed the experiment. All right, so now the deployment is done. If I go to the next screen over, I see that I have an endpoint screen here as well. And under endpoints, I can see what endpoints I've already deployed. In this case, I have a real-time endpoint called my deployment one. When I took the screenshot, you can call it whatever you want. I usually call it something different each time. And then in this case, I have the REST endpoint, which has a really long GoAhead URL and /score, in which case is trying to score or trying to give me a score for the prediction value. So what I'll do at this point is I have a couple of different ways to be able to see this information. So if I go back to my Visual Studio, in which case I have some Visual Studio code that goes ahead and puts in some data, and it reaches out to this endpoint. And I'll show you how in the UI you can just grab the code yourself. So I didn't have to write this from scratch. I just grabbed the sample app and I put it into my console app. So the code that you can use to call the API, it just has the URL in it, and you can change it to your URL. I'll go ahead and start with that debugging. And there's a console app just came out, and some JSON data got spit back, and it said results is true. So all I did was I put in some numeric and string values in this block over here, this dictionary of string. And when I fed it to this prediction method, I was able to then call the API and just get that live data back. Now, if I go back to my browser, we could take a look at that endpoints in my live data. So here's the endpoint I had set up myself. This is the one from last night. And if I zoom out a little bit, there's a REST endpoint at the very bottom, and that's the one that it's calling. And then notice that there is a test tab over here. So here, the test tab, it has all these different values I can fill in. I can click on the test value, or I can go to the JSON editor. This is easier. So what I'm going to do is I'm going to switch over to this text editor on my other screen. And I'm going to go back to this browser, and notice I just pasted in this values 49, F, NAP, and so on, and click on a test, and see I still get some data back here as well. So again, this is a live endpoint. I'm being able to consume it both from my Visual Studio C#.NET code, and also directly from the JSON editor here as well. If you really want to type it in the form, hit tab, 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 you can do that as well. I just find JSON easier to edit, so I don't have to tab out of it. There's also a consume tab up here. So here it shows you that REST endpoint. Again, this is just unique for mine. It is live right now, so if anyone is frantically typing this GUID as you're watching this, you can do that. I will be deleting this instance after this session is done. So if you're watching it later, you won't be able to get to the endpoint later, but now's your chance if you want to do that. And if you check this out, it has all the sample code for me. Tells me how I can enter all those values, and finally call the predict method, and then call that URI that's up there. So again, super simple. It just puts everything in a single class. If you don't like .NET, you want to do some Python, as most machine learning people do, there's a Python sample here as well. You can run that as well as R. Python and R are both very popular in the data science and machine learning space. You can check out the deployment logs as well. Nothing useful over here right now, but in case you wanted to check if something had failed, and so on. Now, the deployment state currently says healthy, but one thing to notice is that, let me see if I can click on this. Here we go. It says healthy state indicates that the service is healthy endpoints available, and learn more about endpoint state. So I'm going to click on that. My JavaScript in my browser is still acting a little weird. So this click may not actually be working. We'll give it a second to load. There you go. So what it's loading over here is the different service states that are available. So, just because something says it's and here we go. So here's what I wanted to look at. Sorry about the delay. Um, the different states that it can go through is transitioning, unhealthy, unschedulable, failed, and healthy. So again, the first few are not the final state. If it failed, then you know that it actually failed. And if it's healthy, that means it's working. But if something is unhealthy, maybe it's deployed and it's not reachable yet because there's some stuff happening in the background, it could become healthy, but you can check out the logs to troubleshoot it further. So I just want to show you that just because it's still transitioning and unhealthy doesn't mean that it's the final state yet. Okay. So I'm going to quickly go over to the PowerPoint. I seem to like that more. The hard disk data, we're taking a look at the Excel file earlier. I just grabbed one sample and I edited some values and checked to see whether it's a true or false. As you're editing the file, one part that skipped over is the upload of the actual CSV file. When I uploaded it, it does give me the option to select one or more columns I would like to include or exclude. So I can include all the columns available, or I can just say, just use these 5 columns of values. It will infer the data type for each of them, whether it's numeric, string, Boolean, whatever, or some decimal point, or you can tell it to process a certain column differently. So again, a lot of different flexibility. The very first step when we uploaded the data file on how you'd like to process it. All right, this is a screen you'd seen earlier already. In the test tab, we took a look at the results. I'm just going to skip over that. There's a form editor and also the JSON editor that I used, so you can get the results. We also looked at the consume tab. It has some code in C#, Python, and R that you can use, and you can use the same endpoint as well. I wanted to wrap up today's session with a brief look at monitoring. Now, here's some Python code. Again, I grabbed this right out from the documentation. Just goes to show how you can just edit the name of the workspace for some starting just some starting code to see what you can do, and take a look at the documentation to see what you can do further than just checking your current status and current details. So over here, I'm going to go back to the browser, and then over here, I do have the notebook open. And I ran this earlier, and it just goes to show that it connected to my workspace, which is called, in this case, MLWS. And I'm checking to see whether the status is running or not. And then towards the bottom, I just check some details, and it gives you some more details about the run ID, the status. It says completed. Some to do more. In the browser, you can edit in VS Code as well, and then uh, interact with it using your hopefully code. Uh, notes that said, if you do want to change the view at the very top, you can change what you're looking at by saving the view. You can edit the view and share it out as well in case you want to share your results. So to summarize, let me go back to the browser really quick and close some of these. So this was the notebook we looked at. This is a tutorial on training classification model, which we had looked at primarily. This one is for evaluating the end results for the different metrics that are available, including how these are all defined. You'll see that AUC underscore weighted definition is here, in addition to other definitions. I've mentioned things like accuracy and precision, but what does it actually mean? Azure ML is clearly defined here. Again, I'll include those links. This one over here is the featurization. We had a whole slide on this, the different featurization and improvements to the data so they can be better classified. This is for the Burke acronym I mentioned earlier for improving the machine learning for AIs that are available. And this you already looked at for the trigrams and bigrams and trigrams and bigrams. The different kind of ensemble learning, stacking, blending, and voting. I'd mentioned towardatascience.com is a place you can learn. And for monitoring, I'd mentioned there was a documentation where you can get more information on how to monitor what's running. This is that page. And last but not least, I had mentioned some very detailed Python tutorials that are available on YouTube. As you can see, these are all super short, 4-minute, 3-minute, 2-minute quick videos that create hours of content. Uh, this is Python for beginners. This one is, let me move over to the next one. More Python for beginners. And then the last one is even more Python for beginners. So I think this is where I'm hitting those uh, JavaScript down. results of a run that I'd done last night. We talked about the different validation processes, specifically on k-fold cross-validation. We saw an example for deployment and how we're able to deploy to an endpoint and how we can test it using multiple ways, whether you want to do it in your own code or just use an endpoint to be able to get the prediction results. We also briefly touched on monitoring, both from the UI and also using code. I did want to end with a quick discussion on ethics in AI and ML. So I had mentioned that we're using heart attack data. So the positive intentions could be that heart attack data could be used to improve healthcare, education, and treatment, for patients. But on the negative side, it could be used as a way to deny insurance coverage for those who need it most. So again, think about what you're going to be using AI and ML for. If you're using Azure ML, is it for the reasons that you're excited about? How do you feel about it ethically and morally? So give that a thought, whatever reasons you're using it for. Have fun with it. Doesn't have to be all boring and dry. Have fun with it. Do something cool. Learn some new things, and make sure that it is in line with what you consider ethically correct. I had promised you a bunch of links that I had open. If I missed something here, just let me know later. But this is all the getting started, the metrics, featurization, the different terms that I used. These websites explain it better than I ever could. And then finally, the Python video tutorials. These are some nicely put together playlists that are available. So again, those playlist links are available here. They're super long URLs, so I've included here so that they're clickable from their PowerPoint. And last but not least, Azure ML documentation. I don't know about you, but when I first started using Microsoft products, it was a long time ago, long before docs.microsoft.com. And I had to go all over the place to find information. And it's very useful to have everything not only in one place, but also to be able to provide feedback. So if you don't like something that's on there, something is wrong, you can provide feedback and someone will read it and help correct it. You can contribute to docs as well. So again, it is really a group effort now. And just to show you how much we covered today, we did some AutoML and how to train a classification model. So that should give you some homework to get started with, a lot of links to follow, a lot of topics to cover. And with that, that is our end slide. This is a thank you slide. It has my LinkedIn. Shahed sees my username both on LinkedIn and in Twitter as well. Back to you, Kevin.
All right. Let's see if my internet holds out for the next couple minutes. Thank you, Shahed. I appreciate you coming out so much. That was super informative. I love seeing the Azure ML stuff. It's like magic almost sometimes. So good. All right, friends. So now's your chance. If you have any last minute questions for Shahed, feel free to drop them. Let's see, while we do that, I'm going to take a quick look to see who we have next month. Unless Drew beats me to it.
Someone was sad I wasn't using an ad blocker.
We have David Garad. I'm probably pronouncing that wrong. Blood, Sweat, and Code Reviews.
Oh, David Giard. Yep. That is going to be David Giard is one of Shahed's colleagues.
He is, yeah. I actually spoke to him recently.
Yeah, indirectly a colleague. So, although I think you both used to be on the same team.
I literally just spoke to him like yesterday.
That's a good time. I love talking to David. He's a fine gentleman. All right. Well, I think the chat's pretty empty. So we'll just go ahead and call it there. It is after midnight where I am. I'm exhausted, so I'm gonna go get some sleep. But Shahed, thank you again so much for hanging out with us today. We really appreciate this. We'll have the replay ready to go in a day or so, and so everyone can come watch. We'll get the links from you, so we'll put all that into the description, make it easier for folks to get to all those resources.
All right. I think to make it easier, Kevin, I'll just email you the PowerPoint. That way you can do whatever you want, post it whatever you want.
Perfect. Yeah, that will work great. All right. Well, thank you everyone for hanging out with us tonight. Thank you again, Shahed. Thank you, Drew, for being here as always. We'll see you all next month. Good night. Take care.
Thanks. Take care.